The sun doesn't move. It's stuck behind a giant gray wall. The wind is cold and unforgiving, and you can feel the ash crunching under your feet. For 6 years, this is what it's like outside. And as you stare up at the endless gray, you wonder, will the sun ever shine again? This isn't a scene from a dystopian movie. It's from Earth about 74,000 years ago. Something strange is happening. A volcano has erupted with an unimaginable force and shot billions of tons of debris into the air, blocking sunlight from reaching the ground for more than half a decade. Plants die, crops fail, and soon millions begin to starve. It's a prehistoric blackout, a volcanic winter, and the closest call in our history to total extinction. It's me, and you're watching this channel. Come with me as we uncover the incredible tale of the prehistoric blackout and how it nearly erased us from existence. The Toba supervolcano eruption. In modern-day Indonesia, there's a lake named Toba. It sits in a crater formed 360,000 years ago when the earth rumbled beneath it and caused it to collapse. Now a new lake has formed in its place. But 74,000 years ago, something unbelievable happened here. Out of the calm waters of Lake Toba rose a monster. One of the largest volcanic eruptions of the last 2 million years just started. It blasted upwards with unimaginable force and blew its top clean off. In fact, some scientists believe it was one of the 3 biggest eruptions in history. So let's try and wrap our minds around just how big this thing was. First, it's measured a 9 on the Volcanic Explosivity Index, or VEI. The same rating given to the 1815 eruption of Mount Tambora, which caused one of the deadliest famines in recorded human history. Second, Mount Street. Helens, one of the most active volcanoes in the United States, erupted in 1980. Its eruption force was measured at 5 on the VEI. Well, the Toba eruption was estimated to be 10,000 times stronger than that. 10,000 times. Over the course of 3 days, the volcano spewed 2,800 cubic kilometers of ash and pumice into the sky, equal to over 300 billion Olympic-sized swimming pools. And third, it sent 2.7 billion tons of sulfur into the atmosphere. To put that number in perspective, it would take the world's largest coal-burning plants 2 centuries to release that much sulfur. But while all these numbers help us understand the magnitude of the blast, they only tell part of the story. Imagine the entire state of Florida disappearing under a layer of ash twice as thick as the Chrysler Building. Or think about the fact that people will be able to see the smoke plume from this eruption from Mars. It was that big. The 1,000-year darkness. As the ash cloud spread around the globe, it began to block sunlight from reaching the ground. Within 2 years, it had circled the planet twice and reached a height of 30 kilometers. Experts estimate it blocked between 20 to 50% of incoming sunlight. Back then, the northern hemisphere was in summer, but temperatures plummeted as cold weather swept across the land. Global temperatures fell by 3 to 5 degrees Celsius, which doesn't sound like much. But considering the average global temperature today is about 15 degrees C, that's a drop of over 30%. For 2 years, people living in places like parts of Asia and Africa saw nothing but darkness. They felt icy winds blow across their lands. Crops failed, animals perished, and famine swept across the population. Scientists are calling this the volcanic winter of the millennium, or even the 1,000-year darkness. To understand what happened next, we need to look at what was happening on the ground. The global volcanic winter. For hundreds of thousands of years, life on Earth had been stable. The climate had remained warm, and the Earth hadn't seen any major cataclysmic events. But now suddenly, everything changed. All across the globe, the cold persisted for years, even decades. Rain and snow turned to sleet and froze on impact. Ice formed on leaves and hung down like icicles. In some areas, it got so bad that ice formed on the inside of trees, killing them instantly. And then it started snowing. It snowed so much that many experts believe massive glaciers formed in just a few months. The ice advanced over the land, wiping everything in its path. At the same time, further south, it got unbearably hot. Some areas of Central Africa, saw temperatures rise by as much as 10 degrees. Torrential rains created massive floods, washing away soil and destroying habitats. Finally, when the ice did melt, it brought with it another disaster. As the frozen topsoil thawed, all the ash that had covered the ground was washed away, exposing the bare rock underneath. Fertile soil disappeared, and with it, so did most plant life. Within a single generation, food chains collapsed, predators died, and ecosystems were completely destroyed. Everywhere, there was massive ecological stress, which brings us to perhaps the greatest question of all. How did humans survive? The human bottleneck theory. Some scientists believe the eruption triggered what's known as a population bottleneck. A bottleneck occurs when a disaster wipes out a large percentage of a species, leaving just a small group of survivors who must rebuild. Today, there are about 8 billion humans alive. But 74,000 years ago, there were probably no more than 10,000, and some geneticists argue that there were only 3,000. That means our population was reduced by 99%. To understand just how dramatic this is, consider this. After the 1918 flu pandemic, around 50 million people died and the world's population fell by 5%. It's estimated that 250,000 years before that, a tsunami in Indonesia killed 227,000 people and decreased the population by 0.3%. But both of those combined are nowhere close to the reduction scientists say may have occurred after the Toba eruption. If true, it would mean that every single human alive today can trace their DNA back to just a handful of survivors. It's almost impossible to imagine. But what makes the theory even wilder is that we might have lost all our relatives during the eruption as well. The Homo erectus had been around for roughly 1.8 million years. The Neanderthals had been around for 400,000 years, and the Denisovans had been around for at least 200,000. All told, at least 15 different species of archaic humans had been walking the earth for hundreds of thousands of years. But after the Toba eruption, all gone, wiped out. Homo sapiens was the only human left, and some scientists say there were only 3,000 of them. To put that number in perspective, the Great Migration of humans out of Africa began about 70,000 years ago, maybe even later. If the bottleneck theory is true, that means the population would have increased tenfold in just a few decades. But whether or not humans would have been able to rebound so quickly depends on the next question. How close did we come to extinction? The Great Dying. After the Toba eruption, the world was a very different place. Everything was covered in ash. It was either scorched or frozen. Crops failed and there wasn't enough food to go around. Many of our relatives, the Neanderthals and Denisovans, couldn't adapt and they died out. But Homo sapiens were a different breed. They migrated across the continent, desperately searching for food. Some scientists believe they may have clustered together along the coast of Africa or near rivers where food was still available. They huddled around campfires, sharing what little food they could find. And as the years dragged on, they grew weaker and weaker. For some, the cold weather made things difficult. Others starved to death. Still others froze and died in the night. Over time, the strongest survived. They were lean and hungry and driven by an insatiable desire to live. Perhaps they hunted smaller animals, scavenged for berries or roots, or used spears to hunt larger game. Whatever they did, they struggled to survive, eating whatever they could find, wherever they could find it. But even still, most died. Only a handful survived, and they rebuilt. They traveled across the world, hunting, gathering, and eventually farming. As the years passed, they began to innovate, using tools, making weapons, migrating to new lands, and forming tribes. They learned to cooperate and work together. And slowly but surely, they repopulated the earth. But not everyone agrees that things were so bad. Did it really happen like this? Not all scientists agree that the Toba eruption caused a human bottleneck. Some believe the crash in population may have occurred earlier or later or not at all. Chris Stringer, an expert in human evolution at the Natural History Museum in London, says, "There is a lot of evidence against the recent emergence of modern humans. I don't think we were hanging on by a whisker. Still, there is no doubt the eruption happened. Volcanic ash has been found in layers of rock across India, Africa, and the ocean floor, proving the scope of the disaster. Whether or not it caused the bottleneck doesn't really matter. The ash, the cold, and the ecological chaos lasted for years, if not decades. Life on Earth was irrevocably altered forever. And perhaps that's the most important part of the story, because it forced early humans to innovate, to migrate, to cooperate, to push forward and discover new things. It may have kick-started the cognitive revolution that led to art, religion, and language, setting the stage for the modern world. Some scientists even believe the extreme stress caused by the eruption may have accelerated brain development in Homo sapiens. After all, our brains only became large enough to speak and draw and plan about 50,000 years ago. Maybe the Toba eruption forced them to grow faster. We survived the eruption, but what if it had been just a little stronger? What if those 3,000 didn't survive? You wouldn't exist. None of us would. This isn't just ancient history. It's your origin story. Now watch. Humans almost went extinct again, but this time it was us. Or check out. Ancient aliens built this. Monumental discovery proves it.